All right, so last time we started section 2.3, and let me go back one slide just to remind you of where we kind of ended up. We had looked at some set operations, and there were 5 different set operations we talked about. We talked about the complement, and the complement means everything that's not in the set. It's in the universal set, but it's not in the set. We actually had talked about that one in one previous lesson. We talked about the intersection of sets, and that's what 2 sets have in common. And then we talked about the union, which means everything in either set. So you kind of make a combined list of everything. Difference means to take a set and to remove a portion of it based on some other set. And then the Cartesian product was a set of ordered pairs. Okay. So we kind of left off on there, and it was a really good place to stop because the other component of this section takes on sort of a different flavor. What you do see is you do see some of the same symbols. So taking a look at this one, we do have that symbol that's got the U, right? So this is a union question. But it's actually asking us to create a visual diagram instead of sort of a list of elements like the other questions were. All right? So the first thing you're going to do is you're going to draw a rectangle because this is asking you to create a Venn diagram. So start with a rectangle. And inside of your rectangle, you're going to have 2 circles because there are 2 sets here represented. There's a set A and a set B. So we're going to draw 2 circles, and they will overlap. So imagine sort of a simplified version of the Olympic rings or something like that. There's several ways to do shading for sets like these. I'm going to show you one of my favorites, and I will tell you that even as your instructor, I'm always learning from you guys too. So the method I'm going to show you is actually not the method that was taught to me originally when I went through a course somewhat similar to what you're doing here. A student showed me this, and I thought, oh, that's just fabulous. So I'm going to show you what the student showed me. What we're going to do is, if you'll notice on this diagram, there are sort of 4 distinctly different parts of this picture. There is the outside area of the circles, but still inside the rectangle. There's the first inside circle, like right here. There's this piece that sort of looks like a, I don't know, a jalapeno or something in the middle here. And then it's a sweet potato, that's what it is. And then we've got this piece over here. So there's basically 4 sections of this graph, okay? Before I get too much into this, let me label my diagram. The first circle I'm going to call A, the second circle is B, and this rectangle is the universal set U. And the next thing I'm going to do is I'm going to number those 4 portions of this picture. And it doesn't matter where you put the numbers, but just so that we're all doing the same thing, if you want to mirror what I'm doing, I tend to put the number 1 in the first circle, the number 2 in the overlapping piece, the number 3 in the right-hand circle, and the number 4 on the outside. And these are just labels. They're not actually representing a number of anything, okay? They're just labels. It's like if I were to count you guys off in groups, I would call you number 1 and you number 2 and you number 3, and number 1 doesn't have anything more on number 3, and it doesn't mean it's about you, or it's just a label, okay? Here's what we're going to do then, is the first thing is we're going to create kind of like a list of these items. So the first set that it talks about in this over here is the set A complement. So if you look down at this picture, you have the circle A. What numbers are inside of circle A? 1 and 2, right? They're both inside of circle A. A complement means we want to write down the numbers that are not inside of circle A. So what numbers are not inside of circle A? 3 and 4. Okay, so that's the first thing. The second item, or the second set that's listed here is the set B. Okay, it doesn't say B complement, it just says B. What numbers are inside of circle B? 2 and 3. After that, we're going to look at this symbol. It says union. What does union mean? All of them, right? So if we want the union, we want all of these numbers. So this set that I'm talking about right here includes number 2. It includes the number 3, and it includes the number 4. And the number 3 is listed twice, but I don't need to list it twice. Okay, those are all of the numbers that are included in either set. So I take my picture below and I shade the areas of the picture that are represented by the number 2, the number 3, and the number 4. So here's number 2 right there in the middle. Here's number 3, it's this circle right here. And then number 4 is the outer part of this rectangle. So the only thing that is not shaded in is the number 1. And that's the diagram solution. It's okay? We're going to try another one. What's different about this one? There's some parentheses. What else is different? It has an intersect and a union, so it has two different symbols to join them. And I think Tangela said also there's 3 sets, right? A, B, and C. So that's actually where I want to start. That will change the way my basic diagram looks. What's it going to change?
3 circles.
I need 3 circles. You got it. All right, so we're going to draw my rectangle. And I need 3 overlapping circles. All right, so we have 3 overlapping circles, and we need to label them. And again, it doesn't matter how you do the labels. If you're trying to mirror what I'm doing, I tend to label them going around A and then B on the right and C as the bottom one. And none of the diagrams you do will ever have more than 3 circles, so you don't have to worry about how do I get an overlap of 4 or anything like that. So you're going to do 2 circles or 3 circles on all the problems you do. And then your outside rectangle needs to be labeled with a U. Okay, we're going to do the same kind of thing we did on the last one, except that we have a lot more than 4 different portions in which we're going to label 1, 2, 3, 4, right? So the way I label is I start in the top left and I work my way across. So there's 1, here's 2 in the middle, 3 on the right. I have 4, 5 in the very middle, 6 in the right, and then 7 on the bottom and 8 outside in U. Again, the labels don't make any difference, so if you put them in a different spot, it's fine. So the kind of work that I'm expecting to see is exactly what we're sort of modeling on the board here, okay? I expect that you're going to write me a list of these things. So the first set is set A. What numbers are inside of set A? 1, 2, 4, and 5. And then the next set that's listed here is the set B. And what numbers are inside set B? 2, 3, 5, and 6. And I've got parentheses, which you guys also noticed at the beginning, right? Those parentheses tell me that that's the part I do first, just like order of operations in algebra, right? You do what's inside parentheses before you move outside the parentheses. So this inside the parentheses says I need to take sets A and B, which I've just listed, and I need to find their intersection. So what does intersection mean? What they have in common. Yes. Most of you are saying the right thing. What do they have in common? 2 and 5. 2 and 5. All right, so I'm going to take that intersection, 2 and 5. That's not 2.5, it really is 2 and 5. And then I'm going to find set C. So what are the items or the numbers listed inside of set C? 4, 5, 6, and 7. And then I need to take these 2 sets, right? And I need to do the union between them. So what is the union between sets A intersect B, which was 2, 5, and the set C, which was 4, 5, 6, 7? 2, 4, 5, 6, and 7. And of course 5 was listed twice. I don't need to list it twice. But that right there is the solution for how I shade. Don't forget, the whole point was to shade. It wasn't just to find these numbers. It was to shade the diagram that's represented by those numbers. So I have to shade in the area that's number 2. I have to shade in the area for number 4. I shade in the area for numbers 5 and 6 and 7. Is it all good? I think we have one more, don't we? Okay, let's give one more try. Okay, so tell me some of the things you're seeing on this one. How many sets? 3, which means what? 3 circles. Okay, so let's draw a rectangle. Let's draw our 3 circles. And let's label them A, B, C, and the universal set U. So what set operations do you see on this one? What's that? Okay, so I see primes. That means complements, right? So I've got complements going on in this one. What else do you see? Parentheses. So that kind of tells me which of these, sets of things to do first. And then what else do you see? Intersections. Everything I do in this problem is intersections, isn't it? I don't have any unions in this one. All right, so let's start. And again, you start inside the parentheses, and we need to start with set A. Before I can do that, I need to have some numbers on my diagram, so let's put those in. So I have a 1, 2, 3, 4, 5, 6, 7, and my outside set 8. All right, so what items are in set A?
1, 2, 4, 5.
Okay, is everybody good with that? And then it lists set B complement or B prime. What does that mean? Everything is not in B. So what numbers are not in B? Good, 1, 4, 7, and 8. And then I'm supposed to take these 2 items and I'm supposed to find their intersection. So A intersect B prime. So what is the intersection of those 2? Have a 1 in both of them and a 4 in both of them. So their intersection is 1, 4. Now I've done everything inside the parentheses. Now I'm supposed to intersect that with C prime, so I need to figure out what C prime is. All right, so what is C prime? 1, 2, 3, 8. Everything not in C, right? So that's sort of the top arc and the outside piece. Next I'm supposed to find these 2, take these 2, the intersection, which was the parenthesis part at the beginning, and then the C prime that I just found out. And I'm supposed to find what they have in common, because this is another intersection. So what do these 2 lists have in common? 1. And that is it, isn't it? They don't have anything else in common, which means the shading for this picture is really easy. It's just this piece right here. Does that make sense? So when you see a problem like this, are you going to just shade something? No. Shading just something means I can't give you any partial credit because I don't know if you're thinking correctly or not. I'm not saying that there are not other ways to do these problems. There are. You can reason some of this out in your head. The problem is that I can't see your head. I mean, I can literally see your head, but I can't see inside of it. So the writing the pieces down lets me see what you're thinking in a concrete way, because I can give partial credit if I can see what you're thinking in a concrete way. Does that make sense? All right.